Welcome to Pacific Mammal Research's Marine Mammal Highlight Series. We are a 501c3 research and education nonprofit studying marine mammals in the Salish Sea off Washington State. In this series, you will learn about different marine mammals as we discuss interesting facts about each species. This is our way to geek out, share some information, and have some fun. We hope you enjoy the series, and be sure to follow us on Instagram to vote for which animal we talk about next. And without further ado, welcome to the PacMam podcast. I'm Cindy.
And I'm Kat.
And this week, I'm sorry, guys, we did not give you a choice. This is a marine mammal highlight.
Sorry, not sorry.
Yeah, but this week we were just like, it was the 4th of July holiday recently, and we're trying to get our schedules, and we're like, you know what? We're just going to decide for you guys this week. So we decided on the Byrdes whale.
Which, for those of you who might have seen this spelled and have no idea how to say it, it's spelled Bryde's whale, Bryde''. I did not know how to say this for the longest time. I think we both had to look it up again before doing this podcast, because it's one of those ones where when you see it written, you're like, oh, Bryde's whale, British whale, like, what is this?
Whale, I know it was different than what it looked like, but I totally forgot that it was completely different.
This whale, yeah. So there we go. Already learning things.
Yeah. So yes, the Byrdes whale. We're gonna do our normal thing, but I'm gonna start off with a kind of a little bit of background, because it sets things up really well for what we know and don't know about this kind of enigmatic, cool whale, but it's confusing. It's a confusing whale is really what we're talking about. So this is a paper, Constantine et al. 2018, so very recent, or relatively recent. Future directions and research for Byrdes whales. And so it just kind of gives a good background, and then kind of where we think we should go. So it kind of sets the stage for what we're going to talk about today. So basically, these whales were not heavily exploited by commercial hunting. Yay! But though it is hunted as part of the North Pacific Japanese Research Program. And as like I said, many of these topics we'll discuss a bit more in depth. The key thing to remember about these guys is the taxonomic status is not resolved. It's very confusing, as we'll talk about. It's often mistaken for other species, and there are different species that are very, very similar looking that we'll talk about. And so it leads to uncertainty about their distribution, their behavior, their conservation status. So that is one of the main reasons why we're going to have some confusion as we go through the information we have about these guys. Some populations are critically endangered, others are small but have high genetic diversity, suggesting there's connectivity, but again, it's unknown. They have unpredictable coastal and offshore global distribution, which means the populations with unknown genetic variation are facing different threats. So it just that all of this leads to a lot of variability and confusion as to what exactly is going on. There's a few populations that are well studied. They have contrasting movement patterns, foraging strategies, and vocal repertoires. So again, a lot of the things we're going to tell you about, well, that's for that population, but maybe not for others. And some of the new future research, or the new research, has some exciting things regarding that, of how different they can be. And so and Kat will talk about population abundance, but a lot of times the individual populations are in the hundreds, some are smaller, under 100. So it's an interesting mix of variability in this species. So basically they're saying we need to learn more about these guys, and they suggest integrative comparative approaches, including acoustic monitoring, trophic interactions, telemetry tools, understanding novel behaviors, and resolving their species status, which I think that last one is really what needs to happen first.
Most importantly.
Right. Let's decide which one of these are actually Byrdes whales and which one of them are different ones. And then we can start to understand a little bit more about that. But that gives you a little bit of a background as to why, again, we're moving in, when we move in here, to some of the confusion that we still have about these whales, and why they are hard to study. So we'll let Kat get into what the Byrdes whales look like and maybe some of their lookalikes.
Yeah, so I guess it's with that introduction, why don't I just start off by saying there are two subspecies of Byrdes whale that we're going to be mostly focusing on today because they are technically Brydes whales. Yes.
whales.
So those are the common Brydes whale and the Eden's whale. So those are the two. I know, it's really cool. Those are the two subspecies that we're going to be talking about. There are other two primary players here that we're also going to be referencing, and that's what Cindy was alluding to. One of them is a pygmy form of Brydes whale called the Amura's whale, which is, again, a separate species. And the second of those is the Rice's whale, which, again, is a separate species, but they're both related to the Brydes whale. So I'll get into what they all look like here in a second, but just, again, these are the four primary players that we're probably going to be referencing here, even though we are predominantly talking about the common and the Eden's whale.
Yeah, and the Amura's and the Rice's whale are more recently decided that they were separate species. So Correct. That's why the long-term research here is really like, well, who are you researching? You don't know, because back in the day, they were all just different types of Brydes whales, or they thought, and so it's been, the taxonomic stuff is still a little confused.
Very confusing, yeah. Okay, but just again, a little bit of background here when we get into the appearance and distribution. So what do they look like? So Brydes whales are rorquals, which is the family that includes things like blue whales and sei whales. They're very torpedo-shaped. They're very long and slender whales. The Brydes whales typically have a dark gray back with white sides and belly. Again, like other rorqual species, they do have this very distinctive torpedo shape. So they have a very small hooked dorsal fin, which is about 2/3 of the way along their back. Otherwise, they're just this very long, slender, almost cigar shape. Their head makes up 1/4 of the entire body length in Brydes whales, because of course these guys are baleen feeders. So they are feeding on, I'm sure Cindy will get into, but things like plankton and the small little crustaceans in the ocean. The common and Eden's whale have 3 ridges in front of their blowhole. So this is one way that they can distinguish these guys from other rorqual species, which typically just have one single ridge in front of the blowhole. The Brydes whales have up to 70 throat grooves, so typically between 40 to 70 throat grooves, which facilitate that baleen feeding, right? So they're engulfing the water and then they're straining it out through the baleen.
And I would say the rorqual, the reason the rorquals, the one thing that they have, that is the throat. Those animals have the throat grooves versus other baleen whales that don't have those grooves. So that's what rorquals are specifically. Right.
And they have up to around about 400 baleen plates on each side of their mouth to assist with that filter feeding. So again, it kind of makes sense if you have up to 400 baleen plates, your mouth is going to need to be pretty big, which kind of makes sense as to why the head is so much of the body.
You need a little real estate for that.
Yeah, exactly. So the common and the Eden's Brydes whales grow up to about 50 feet long. So it's about 45 to 50 feet. The males are slightly smaller than the females. And these guys weigh up to 25 metric tons. So it's between 12 to 25. So that's a pretty big weight range, actually. The Eden's whales are slightly smaller than the common Brydes whales. And this is where we start to get into a little bit of that confusion with these other species that look very similar. So that's what the Brydes whale looks like, right? The common and the Eden's whale have these kind of fairly consistent coloration, whatnot. The Eden's whale is slightly smaller. Then we get into the Amura's whale, which is basically a pygmy form of Brydes whale that, again, as we said, has been designated as a separate species. It was first identified, I believe, in the late 1970s, so very recently. The one main difference with these guys, obviously they are smaller, right? They are seen as a pygmy form, but they have a unique asymmetrical black and white markings on their head and jaw. So this is, I think, one of the main ways that these were distinguished from the common or Eden's Brydes whales. The lower jaw is white on the right side and black on the left side.
Cool. It's like from the 80s or 90s, you know, when you have like half and half color, like so cool.
Right. These guys were so on trend for the late 1970s. So that's the Amura's whale. So again, this is one of these separate species that are very closely related to Brydes whales. The second of those that I mentioned was the rice whale. So these guys are, again, that uniform gray on top, but they have a pale or pink belly. So as opposed to the white of the common or Eden's Brydes whale. But otherwise, the rice whale looks fairly similar. Again, the head makes about 1/4 of the whole body length. Again, they have these 3 rostrum grooves in front of the blowhole. I keep wanting to say dorsal fin. In front of the blowhole. So these guys, almost more than the Amura's whales, do look very similar to the common Brydes whales. So this is where, like Cindy mentioned at the top, we get into some confusion around which one are you actually looking at. And again, if you've ever seen marine mammals in the wild, you'll know that it can be very tricky, and you get a very brief opportunity to figure out what you're looking at a lot of times.
A lot of times see pictures put on Facebook pages are like, this is the only picture I got. What do you guys think? And everybody's like, I don't know.
Right. Yeah, it's not as easy as you might think. The other confusing factor to throw in here in terms of visual identification of these guys is that they do look very similar to sei whales as well. Sei whales are larger, but out of context and in the open ocean, it can be very difficult to discern, especially if it's just a brief surfacing where all you're really seeing is the back and the dorsal fin. It can be very difficult to distinguish.
You can see those 3 ridges versus the one, and then that's great. Correct. You're not going to see that very often, not always. So
exactly. So that's another point of confusion with these guys. They're very enigmatic.
Yeah, and I like to say too that when they figured out the different species, the Omuras and the Rices, that's due to both morphological, but a lot of it is genetic work that they've done. So that's why more recently, and we'll talk about in the fun facts actually about how those animals ended up becoming separate, and the timeline that takes. But it's genetics is one of the key things that helped us with that.
Yeah, for sure. So getting into where they live in the world. So again, these 2 subspecies of Brydes whale, the common and the Edens, are found in tropical, subtropical, and warm temperate oceans. So pretty wide distribution, including the Atlantic, Indian, and Pacific Oceans. So basically they can be found in all oceans around that 40th parallel. So certain groups and certain populations have more hotspots within that range, I guess. So the Eden's whale, for example, are typically more found around like the Bay of Bengal, Bangladesh, India, Thailand, Vietnam. The common Brydes whale are more typically in the Atlantic and the Pacific. So they do seem to sort of segment a little bit. Also, the Eden's whale does prefer those more coastal areas, while the common Brydes whale is typically found in more pelagic waters. The other complicated thing with these guys is that some populations are migratory while others are not. So that actually makes them unique among migratory whale species, is that some populations migrate while others don't, which is very unusual. Typically, that is a species-wide trait. Even if it's small and short-term migrations, there is some sort of migratory movement, while having this sort of resident versus migratory split is very unusual.
And I think we might end up seeing that with harbor porpoises. There's ones that migrate on and offshore more in certain areas of in Europe, but in other areas like where we are, that don't seem like they do that. So it's interesting that there are some species that are like, we're gonna do our own thing. You guys can do that, we'll do this. Whereas other species are like, everybody does it. Yeah, exactly.
So basically, in summary, Brydes whales can be found effectively around that 40th parallel throughout that sort of tropical, subtropical, and warm temperate water.
Which is unique because usually the baleen whales don't hang out in warm waters year round.
Yes, that's a good point. I think blue whales might be one of the only other ones that you would see in those more warmer, subtropical to warm temperate. I know, that's true.
It's so big, but we can't find them.
That's true. So just briefly, because we've been referencing them for context, these other 2 species that are so similar, and you can we'll start to understand why some of the confusion around identification also happened, because their ranges do overlap with the Brydes whales. So the Amura's whales are typically found kind of around, again, like that sort of Indonesian, Indian Ocean area. They have been seen off of the northwest coast of Australia. I actually just found a paper that was talking about how they are more widely distributed than we first thought, now that we know what we're looking at. But again, that would overlap with a lot of that Eden's whale ranging. So again, it can get a little complicated as to which one are we looking at? How do we know that we're looking at this one or that one? In terms of the Rice's whale has been consistently located in the northeastern Gulf of Mexico. So that one does seem to be more resident to that Gulf of Mexico area, typically around the continental shelf. And apparently they are the only known resident baleen whale in the Gulf of Mexico. So those guys, at least, they seem to have a specific spot that they hang out in, and that's kind of where they're found.
And what's interesting is that I was reading another paper about a skull that was, or an animal that had washed ashore in North Carolina. And then after they decided the rhesus whale was genetically different, and it's the Gulf of Mexico thing, and they're resident there, they compared it to that, and it was a rhesus whale that was.
Oh,
so I was like, but wait a minute, you just said that these guys stay in the Gulf of Mexico. So I mean, that could have just been
interesting
that was doing around, walkabout and lost his way and whatever. But I thought that was interesting that they stayed. But apparently, there's one guy that was like, "I'm gonna go visit North Carolina."
Huh?
Yeah.
Interesting.
Yeah.
So that is what we have for the Brydes whale and relations, appearance and distribution. I feel like this is going to be like Brydes whale and others.
Yeah. Well, I think we're basically covering the other two in this podcast because there's not
kind of sort of. Yeah. Well, and that's the thing where we can see in future if we want to get into these specifically, but it is, I mean, that's what's so interesting, right? And I think it's very important to reference the fact that there are these very similar looking whales that we didn't know were different until relatively recently, because that does change how we're then viewing Brydes whales proper, right? So hopefully that didn't confuse you guys and
confused me when I was going through it.
I know. Common and Eden's whales are the actual true Brydes whales found around that 40th parallel. Amuras and Rice's whales have their own little pockets.
Their own little things, doing their own little things over there.
Yeah.
Well, so, and what the behavior and diet that we'll be going through now is, this is mainly for Brydes whales, the two, Eden and the common, but probably fairly similar for the other two species that are really close to them. So for diet, they, again, as Kat was saying, they are baleen, they're baleen feeders. So they do eat, but they eat a fairly wide variety: the krill, copepods, red crabs, which I had never heard of before, shrimp, plus schooling fish like herring, mackerel, pilchards, and sardines. So those smaller schooling fish. They have found squid remains in some stomachs, and I want to put a pin on that because there's some new research that's very interesting and very cool for conservation that we'll talk about that has to do with squid. So squid and other cephalopods may be more prevalent in some populations than others, but mainly they are the plankton and small forage fish. They eat 1,320 to 1,450 pounds of food per day. I mean, it's bonkers. Mind blown. So it always amazes me every single time that baleen whales are so huge and they eat some of the smallest things and how much of that they have to eat to maintain their body weight per day. It's just bonker balls. So because they live in these warm and subtropical waters, again, normally baleen whales don't eat or at least they don't eat very much in the I gotta get this backwards, in the winter time when they're in the hot latitudes, and then they go up and they gorge themselves in the summertime in the high Arctic where it's high productivity. But these guys are living in relatively poor nutrient waters year round. So how do you get 1,500 pounds of food a day in areas that aren't necessarily as productive? So that's probably why they are found in more pockety type distribution, because they are often found near high productivity upwelling. So when the deep, cooler, rich waters get upwelled into these areas and produce that productivity that can sustain them. And so they have a wide variety of ways to forage, which is, again, a little bit different than a lot of other baleen whales. A lot of baleen whales stick to one thing, like they skim, they lunge, they bubble nut feed, they whatever, or they have one or two that they do. These guys are known to skim. They've known where they just kind of like, you open your mouth at the surface like a shark and like and skim along the surface. They lunge like humpback whales do, where they will corral them into the schooling fish into balls and then lunge through them. And then they also do bubble net feeding. And then I'll also put a pin in that because there's some new research showing some other interesting foraging behaviors that they do. So they're very varied again. Yeah, it's really interesting. So and it's maybe linked to what they're specifically eating at that particular place. So they're pretty interesting. The feeding events also involve usually multiple other species. So there's like gannets, common dolphins, seals, sharks that will be around in the same area, which is similar to other species, but I think this is even more common for these guys. So that's what they eat and the various ways that they are able to do it.
Very cool.
Yeah, I was impressed with how variable they are. So like most baleen whale species, these guys are not super social in the context of having large groups. They are found alone or in pairs, usually no more than 3. Reports of up to 20 whales have been given that are usually loosely grouped in feeding areas. So this goes back to that, are they actually grouped together, or are they just in a place at the same time because there's lots of food, right? Feeding aggregations versus actual social interactions. But there is some research that I'll put a pin in that too, that we actually do have some information, at least somewhat anecdotal, but about associations for these animals. But they will spend most of the day within 50 feet of the water surface, so they're not really super deep divers. They can get up to 1,000 feet, but not normally going too far. Their dives last for about 5 to 15 minutes, and they maximum is 20 minutes. I think the average is really kind of around 8, 9, 10. They don't fluke up when diving, so like many other species do. So getting their IDs would not be from their flukes. Their IDs would be from their the body and the dorsal fin. They swim generally like 1 to 4 miles per hour, but can reach 12 to 15. So they can sprint, right? And these the torpedo shape lends to that, right? They can move faster. And so what's interesting is that I guess these guys specifically, compared to other baleen whales, can change directions unexpectedly when swimming. So they are very agile, apparently. And I've never seen that with any other baleen species, like that say that they can do that specifically, right?
Yeah. I mean, I think the minke is the only one that I think they've talked about being a fairly agile whale species, but again, you don't hear about them necessarily doing the quick turn necessarily.
Yeah, and they're the one of the like I think the second smallest baleen whale, so it makes sense that they would be able to do that. So these larger animals are apparently very agile. So that was kind of cool. Their exhale when they blow can go 10 to 13 feet in the air, that's really tall.
That's like 1.5 heights of a building,
right?
Of a room, I guess a room. Yeah, I think a room's usually like 10 to 12 feet high, right? Depending on the height of your ceilings.
8 to 10, like 8 is normal, and then if you have 10 feet ceilings, you get that extra.
Okay,
so yeah,
like 1.5. Wow.
And then they sometimes make short, powerful sounds in low frequency that sound like moans. And I'm gonna put a link. I found a link that has the recording of them. So I'll put that in the show notes. You guys can listen to it. It's cool. For reproduction, we don't know a lot. They are sexually mature at 9 years. Even though I don't think we know too much about their age. I think Kat will probably talk about that later, but we do know apparently 9 years. 9 years that's pretty much great. Between like 8 and 10 years, they become sexually mature. Their pregnancy lasts about 10 to 12 months, and they nurse for between 6 and 7 to 12 months, really no more than 12. They can have a single calf every 2 to 3 years, and they mate year-round for inshore populations. But whaling data showed that some offshore populations conceive and calve in the winter months. Okay. But there's a peak of the breeding and calving occurs in the autumn for the ones that mate year-round. So once again, confusion. Right. So it looks like some populations can mate year-round, but maybe have a peak in autumn. Other ones, offshores, really calve in the winter months. Maybe they're all a little different. Who knows? We still have to figure that out. We just don't know as much about these whales because we've just recently really figured out who they are, and not even really figured out who they are. So we're still in the midst of that. So that's what we have for their diet and behavior and reproduction. And we are going to take a quick break, and we'll come back with these status and threats, and then some of those pins we put in there for new research of some cool stuff that's happening with these whales. So we will take a quick break, and we'll be right back. All right, we're back. Back to the Brydes whale. So now Kat is going to talk about what we know about how many there are and what's threatening them.
Yeah. So, as you might imagine, we don't have firm population counts for these guys, shockingly.
Okay.
So several sources have indicated around about 100,000 Brydes whales in total. It is estimated that about 2/3 of this population are found within the Northern Hemisphere. So it does seem that they are mostly found in the Northern Hemisphere, although they can be found in that 40th parallel in the Southern Hemisphere as well.
Huh.
And within the US waters, again, as we've talked about on other podcasts, in order to properly conserve, these are often divided into different stocks. So in the US, we do have Brydes whales divided into 3 different stocks. We have the Eastern Tropical Pacific stock, the Hawaiian stock, and then the Gulf of Mexico stock, which is different from the Rice's whale, which I'll get to in a second. This is for the Brydes whale specifically. So again, the Gulf of Mexico stock are endangered. It's thought that there's only about 100 whales down there. The Hawaiian stock is estimated between 350 to 500 animals. The Eastern Tropical Pacific stock is around 11 to 13,000 animals. So it does seem like there are more within that sort of Eastern Pacific range, at least within the US waters, or what are considered to be US waters. The other thing I will say about this is that, just to kind of indicate that, as Cindy mentioned at the top, we don't really know, we don't have a good total population count, nor do we really have a good idea of the individual population counts either. So as of 2016, the Brydes whale was actually considered to be critically endangered in New Zealand because there are only about 200 left in that area. So this is kind of a good example where if you say, oh, there's about 100,000 Brydes whales worldwide, it sounds like that's pretty solid, right? That's an okay population count. Once you start actually niching down and realizing there are these little populations that live in these sections, it's likely a very different picture. So this is really important to remember. And like I said, we've discussed this on other podcasts where when animals have such a wide range, it's really important to look at the specific populations to see what the health of these populations are, because it's unlikely to be uniform across their distribution.
Right, and that's what saying that review is like some populations are critically endangered, some of them are doing great. Like if they're equal across their range, and it really is important to understand that for their overall conservation and how much mixture there is, right? So maybe these two populations are separate, but they do this mix, and that mix is really important for the little bit that happens. And if you take that away, that can change the genetics of each of those populations and cause things, inbreeding and things like that. So
yeah, exactly. All these different implications. So the Brydes whales are protected by the Marine Mammal Protection Act, the CITES Appendix 2, and the SPA Annex 2 throughout their range. So basically, they do have coverage of some level of protection throughout their range. We'll get into that in a little bit more detail in the threats section. Just really briefly, because again, we've been referencing these guys throughout. So the Amura's whale, these cousins, are about 50,000 in their population, we think. They're sort of the pygmy version of a Brydes whale that we do now know is a different species. And then the Rice's whale, those Gulf of Mexico guys, there's only about 50 individuals. I think 51 was
really
the
critically endangered.
Yeah, 51 was the number that I kept seeing. So that population of animals, and again, this is where it's so important to recognize this is actually a unique species. This is not a Brydes whale. This is a different species, because that suddenly makes a huge difference to their population numbers. So this is where teasing all of this out with now being able to utilize genetics in addition to morphological differences, this is where this becomes so impactful and important for conservation.
Because say you had a few hundred of the Brydes whales in that area, and those 50 were part of that. Well, now that's 350 animals. That's fine. But now when you realize, oh no, they're not mixing. There's only 50 of those guys. That's a completely different story.
Yeah, totally different. So just wanted to reference that just for context with some of these other whale species that are very similar. So with reference to threats, one of the biggest threats for the Brydes whale is actually anthropogenic impacts. So this is sort of it's threefold, really. So first of all, literal physical impact from boats. So these guys are really, really impacted and very susceptible to vessel strikes. They are living in often coastal waters. They're living in these latitudes where there's often heavy shipping and vessel traffic. They are apparently the third most commonly reported species struck by vessels in the Southern Hemisphere. So they're very susceptible, which is interesting with you saying how agile they are in the water. That's really curious.
It is, but also I'm going to talk about in the new research when they rest.
Ooh, okay. Put a pin in that. Excellent. Because I was curious. I'm like, as soon as you said that, I'm like, wait a second. So then why? Okay, we'll get into it. Love it. So vessel strikes and of course disturbance from shipping is a big problem for these guys. The second impact that we have on them is of course underwater noise. So again, because they're living in proximity to these coastal areas, these pelagic areas with a lot of traffic, there's a high amount of sound pollution happening within their environment. So as we've talked about on other podcasts, this can have both direct and indirect impacts on the animals. So masking is basically when the sound externally is covering up the sounds that the animals are making. It's like when you're at a rock concert and trying to yell at your friend and they can't hear you, your sound is being masked, right, by the noise. So that's, of course, really impactful for communication and foraging. But then also that has longer term implications. If they can't find food, that's going to lead to a depletion of their resources and their fat stores. If they can't find their other whales, they can't mate successfully, right? So that actually has a lot more knock-on impacts for their life history if this ocean noise is consistent and ongoing. The third impact that we have on them is, of course, direct hunting. So like Cindy mentioned, these guys were not super heavily targeted during the huge whaling boom in the early 20th, the 19th century. I always get that muddled up.
No, we still did it into the 20th century.
Well, true. But I mean, that was, moving into that area. Yeah. Mostly because they're smaller, right? So they were fishing and whaling for the largest whales first, because of course that's the biggest haul. So these guys did start to be impacted by that towards the end of the big whaling effort, because by that
got rid of all the big whales.
Right. All the big whales is very similar to the fishing dilemmas that we have now. All the large fish have already fished out. And so they are going after smaller and smaller species. So while their populations were not necessarily heavily depleted historically, there are still active hunts going on. So off of Indonesia and Polynesia, Bryde's whales are still hunted. Some parts of Japan are still hunting Bryde's whales as part of their scientific whaling program. So again, even though they're not necessarily historically having huge impacts from whaling, this is still something that is ongoing today. Very similar to minke whales, actually. That's kind of a similar story to what minke whales experienced, and they also are actively hunted.
Yeah, it's weird to think about whaling still really happening today in the same context as it was before. So it's interesting to hear the ones that weren't hit then are now being hit now. Maybe not to the same extent, of course, but still.
Yeah. And I think, I mean, especially, for us living in the US and North America, whaling is not part of the culture here typically. I mean, it is for some tribal nations, but I mean, for the most part, it's not something that has really been part of our culture here in recent years, where again, parts of Indonesia, Polynesia, that's still very much part of their lifestyle. So the final major threat is really, of course, predation. So these guys, as one of the slightly smaller baleen whales, these guys are predated upon by orcas, of course. Being a rorqual, they tend to use flight as their main method of avoiding capture. So they can, again, some of those bursts of speed are likely when they're being pursued and chased by orcas. So that is, of course, another concern and another issue for these guys. Those are the main threats for Bryde's whales. And then, of course, obviously inbreeding, when you get into some of those more restricted populations, that's going to become a problem as we go.
And I did see there was a recent paper about an orca predation event on a Bryde's whale I forgot where it was, but
I think it was in the Sea of Cortez, I believe was one.
Yeah, and they were like, "Oh, it's new," and so they had documentation. So
yeah,
I didn't put that in the new research though, because I was like, well, the cat's going to talk about killer whales eating them, so that'll be fine. So moving on then to the new research, and I honestly was surprised at how much kind of cool research was going on for these guys, because they're just they're harder to find. We're still figuring out their taxonomic status and stuff. But there's some really interesting stuff happening regarding their behavior and foraging and stuff. So there was a paper in 2009, Alves et al., and this is the one that talked about associations. Super cool. So associations and dive profiles, insights into foraging behaviors. So they used time depth recorders that they attached to them. And this was, I think, the first ones to analyze this, these TDRs that were attached to a Bryde whale. So it was the kind of the first time they'd done that. This is off Madeira Island, and they did it was a pair of whales that they did. So they had these dive profiles, and what they found is that during the time where both of them had it on, right, they put one tag on and then they put the other tag on, so there a certain amount of time, and then one of them fell off. So over the whole time, there's a certain section where they both had it on at the same time. But there was temporal synchrony in the dive of the two whales. That so they were actually, they did 23 dives together. So they were like seemingly hanging out together and doing the same thing at the same time, which is interesting because, again, we think of baleen whales as pretty much loners in what they do. They did do molecular sexing on one of them, and it showed that it wasn't a mom and an offspring. So I think the larger one was a male. So they're like, okay, well, it's not a younger juvenile and a mother. So, and also then they did photo ID on this particular population. And I cited those animals together 7 times before, in 2005, 2006, and 2007.
Interesting.
So, and like the summers of those years, I think. So that shows that, I mean, that was in the paper was published in 2009. So over 3, 4, 5 years, they were seeing these same individuals together. So it showed that they may form stable associations for at least part of their life, which is very interesting. We don't really see much for baleen whales as far as we know. So they did surface dives during the day and night, but deeper dives during dusk and night, and then sequentially shallower deep dives at early night and deeper dives at early morning, which is likely correlated with the zooplankton doing their vertical migration, their diel vertical migration patterns. So luckily they're following that deep scattering layer kind of thing as they're coming up and going back down. And so, like other baleen whale species, they may use different strategies to feed upon different prey species during the day versus the night. And I'll get to that in a little bit. A couple other ones that were done by the same person. This is Izadi et al. In 2018. So we're just talking about nighttime. Now we're going to talk about the nightlife of the Bryde whale. What are they doing at night? Hanging out. So they did D tags, archival tags, and they looked at sound and movement on these tags. And this is in the Hauraki, is it Hauraki Gulf in New Zealand? I think I'm saying
the Hauraki.
Yeah, Hauraki. Okay, I said right. Yay. But they're basically looking at the resting patterns. So by listening to the tags, they can see the water movement and hear like the rushing versus the calming, and then looking at some of the dive profiles to be able to see. So they use proxies for activity and speed, and changes in dive patterns such as dive depth and shape, fluking and respiration rates to basically tell when are they resting versus when are they running around. So they showed strong diel differences, so differences between day and night, and long periods of low activity occurred exclusively during the night. So this is what we were talking about before about ship strikes. At nighttime resting whales are going to be more vulnerable to vessel strikes. And what can the vessels not see? The whales, because it's dark.
Got it.
So that
makes so much sense.
That may be why they are more prone to getting hit.
Okay.
Even though they're agile. You know, if you're like sleeping and all of a sudden the ship comes at you, you're not going to be like, whoa, run really quick. So they thought that either they rely on senses that are less effective at night for finding prey, or they the prey that they're doing aggregates less densely at night, so then they use that time to rest. So then that same author did one in 2022, and these are feeding tactics, again in New Zealand. So these are the Hauraki Gulf animals. So again, as we talked about before, the different populations, this is maybe specific to this population. It could be similar to other populations, but there's a lot of variation with these guys. So they use multi-sensor tags and visual observations from drones and boats. And they found that the whales employ specialized feeding tactics matched to prey type. So this is why they are so varied, right? They have the ability to go, oh, I'm going after this one, I'm going to use this particular foraging strategy. The zooplankton at the surface involved multiple head slaps, presumably for aggregating the zooplankton, followed by a side lunge. So they I think they go splat, and then they all move to one side, and then they side lunge through the patch.
Cool.
The plankton patches, they swim in tight circles, performing up to 33 lunges per bout. And remember,
that's a lot of energy.
It is a lot of energy. I was supposed to say, like, there's some large animals, and I was recently doing a thing for my students, and I think a breach for some large whales is the amount of energy for a person to do a marathon. So if you're doing like 33 lunges, that's a lot. And then when they were hunting the fish, they did faster vertical lunges. So just slightly different. But for both of those, the lunges ended with a 90-degree roll, and I thought that was likely to minimize the prey escape at the surface. So they're lunging and then making sure they don't get away. So they noted that the plasticity in the diet, we've talked a lot about plasticity in other podcasts, right? Being able to have this variation is very helpful. If one prey item goes out, you have the opportunity to be able to eat something else. So the diet plasticity and the dynamic behaviors are key to increasing their foraging efficiency. And this is even more important because, again, they are in lower productivity, warmer waters. You have to have a good repertoire of things to be able to do for whatever's there at the time. So the next one is very recently. So this is Segre et al. 2022. And this is what I was talking about, entanglement risk and the squid. So they found that a new way that these animals are eating, didn't know before, they do high-speed chases along the seafloor. And so this, I actually don't know what they were going after here, but this is in South Africa, and South African are doing an experimental octopus fishery where they put traps down on the bottom. But what they found is that resulted in unsustainable rate of fatal whale entanglements, particularly the Byrdes whale. And to the point where they would be wrapped around so much that the jaw would be cut off from the lines and everything. Yeah, it's really bad. So they use suction cup biologgers to document this new feeding behavior. What they do is they chase down their prey. And again, they can go really fast, right? They're sprinting, basically. These inshore whales in the spring, and they maneuver along the seafloor for extended periods of time. So they're just like cruising the bottom and then do multiple direction changes at very high swimming speeds. So basically, it's similar to what we see with the North Atlantic right whales, right? Where they're swimming through and then they like rotate through all these lines that are in the water and they just get wrapped up. Well, what happens is the traps are put down, and then there's a line that goes up like that, and another line that goes up like that, like little rainbows.
Okay. So
now you're zooming through and doing these direction changes all quick. You're getting wrapped up in these lines. So what's really cool, and this is my favorite part about this, is like science being used for conservation. They documented this with these biologgers, and then they went to the government and they're like, this is unsustainable, this population. So the work assisted in the implementation of mandatory changes to the fishing gear, where they sink the ground lines between the traps, they redesign the vertical lines, and they have an acoustic or time release mechanisms on the sunken buoys so that they can easily get them up. That have drastically reduced entanglements, and there have been no entanglements since 2019 of Byrdes whales.
That's incredible.
Isn't that amazing?
That's so cool.
They showed the value of using species-specific behavioral information to make directed conservation decisions, and that the government listened, right? The South African government was like, okay, we're going to make these changes so that the octopus fishery can still occur, but we're reducing how these animals are being caught. And I think humpback whales also got caught in different things as well. But they also made rules of like, if you get one, you're done, you're out. You have to stop fishing completely. Like they're really hardcore. And so I think that kind of strong, ideas about it breeds innovation, right? If you can't have any of that, you're going to figure out how to do it without getting those entangled, right? And it shows that you can. So they're still monitoring it and making sure that this continues to be a good path forward to see if the octopus fishery, again, is still kind of experimental. So they're still figuring out that can happen. So anyway, very cool story about using science to do direct conservation changes and save whales. Then the last one I have for the new research is a community-based population monitoring in California. So they used scientific boat surveys and citizen science. They used, and this is really interesting, they used a mobile app like we have for the porpoises and many other groups have for their species. But then they also used a fisherman community group chat. So I think it's called WeChat is a popular one that people use. And what this one was looking at was that basically it was very helpful information. The locations that were located by the community scientists were consistent with what they found with boat transects, but they saw that the sightings distribution was larger than previous surveys. So it was helping them understand that these animals have a wider distribution than we were getting just from the science alone. But what's interesting is the group chat had significantly more reports. They had 42 reports on the group chat and only 5 reports on the mobile app. It's a different way of mobilizing the community scientists. Apparently that was again, making it more of a community thing. So maybe more people were more likely to chat about it and log it rather than just doing it in a specific app.
Well, and I will say too that the fishermen are out consistently where most citizen scientists are not. So the fishermen are going out like every single day, and if they're seeing them every single day, well then cool, they're going to actually notice that, where the citizen scientists might be going out maybe once or twice a week.
Right, for sure. But interesting that the fishermen had both the app and the community group chat, and they use the community group chat.
Oh, I see what you're saying. Okay,
yeah.
Got it.
So it's interesting to see different ways of engaging community scientists, and that it can again provide really great information. So that was in Zhang et al. 2021. So lots of cool stuff that's being done with this, and they did say that it was confirming the right species. They were looking at the Byrde whale, not someone else. So on that note, that's all the kind of cool research. I had to stop myself again from continuing to dive into all that stuff. But we're going to end on the fun fact about the Rice's whale, and this is.
I have one fun fact before we do that.
The name. Yes, the name.
Yeah, so I have 2 fun facts. I think most of the other fun facts that I had you already covered, so that's great. So for lifespan, these guys can live surprisingly long. So they live about 50 to 70 years. I believe the longest lived animal they found was like 72.
See, I all the things that I said, they're like, we have no idea.
Yeah, there was one, and I think this is the thing. I think it might be based off of that one animal they found that they knew was 72. So they're like, okay, that's probably the upper range. So conservatively, it's likely 50 to 70. So I'm not sure how much research there is to support that. But there is that kind of rough-ish range.
It's similar to the baleen species too. So I mean, it makes
I'm sure that's also kind of what's informing that as well. But as we mentioned at the top, this is kind of an unusual name, right? Byrdes whale. So they are actually named for Johan Bryde, who was a Norwegian. When you understand that he was Norwegian, saying the name differently makes a lot more sense. So he was apparently responsible for building the first whaling stations in South Africa in the early 20th century. So I would imagine that he was probably one of the first ones to have seen these whales or comment on them or whatever. Right. And so became their namesake.
Oh, interesting.
Mr. Bryde.
Just when you said that, I just remembered, I have a 3-year-old, so I watch a lot of kids shows. But there's one on Netflix called Sea of Love, and it's about a whale and his friends, and it's super cute. But the song goes, Bryde, Bryde, gentle whale. So it must be a Bryde whale.
There you go.
Didn't even connect until right now. Pretty cool. So go check it out.
The things you learn on our podcast, guys.
It's very wide-ranging. Okay, so the last fun fact is about the Rice's whale and how it became a separate species from the Bryde whale. And so there's a good timeline, which I'll have in the show notes. But in 1965, Dale W. Rice had the first published evidence of the Bryde whale or Bryde whale type present in the Gulf of Mexico. So 1965, first, it's there. Then 30 years later, 1999, NOAA Southeast Fisheries Science Center determined that they are year-round residents of the Gulf. Right, so it took us another 30 years to learn this. All right, and then in 2003 is when the Japanese scientists described the Omura's whale. So they had known about that before, but again, it didn't happen until 2003. You said like the 70s is when they kind of knew about it. 2003 is when it was described and said, this is definitely a separate species. Move on to 2014. NOAA Southeast Fisheries Science Center described the rice as well, the Gulf of Mexico whales, as a distinct lineage of a Bryde's whale, and they became known as the Gulf of Mexico Bryde's whale. So still confusing because you're saying they're not the same as a Bryde's whale, but you just called them the Gulf of Mexico Bryde's whale. Well, they're related, but you know. And then it wasn't until 2021 that there was a formal scientific description of the Gulf of Mexico Bryde's whale as a separate species due to morphological features of the skull and high genetic divergence that distinguishes them from Bryde's whale species and subspecies. And they named it Rice's whale after Dale W. Rice that found it. But 1965 to 2021. Right.
That's wild.
Like 60 years or something like that. 40, 40 is 2005. So yeah, like 55-ish, something like that years.
Wow.
So I like this as an example of why it takes a long time for us to, and us as scientists, and to all agree to get the evidence that is needed. And then with new genetics coming out, right, that's really probably why this was able to happen, right? Because morphologically, like there can be differences and wide variation, but still be the same species. And so the genetic stuff is really helping us see that, but also making it more complicated as to what exactly where's the line between genetic variation and an actually separate species. So that again just helps to explain why it's still so confusing, because we're only just recently we're like, that's definitely a separate whale in the early 2000s, from the 60s and 70s when the Umaro's whale and the Rice's whale were both initially described. So it takes a while.
Very interesting.
Figure that out. Yeah. And we're still doing that for a lot of species. There's still these little pockets. You're like, wait, what are you guys? Are you? Yeah. Even with killer whales, there's still there's a lot that are actually trying to have some of the ecotypes distinguished as separate species. So new frontiers happening in the taxonomic world as we get more and more information. So
yeah, well, and I think you said it's a testament to the fact that as our technology changes and improves, we can refine and refine and refine our ability to protect these animals. I think that's the biggest thing is being able to use these advances that we're experiencing in our technology to affect change in a really positive way, where the more we learn, the more we can actually then refine our system and say, oh, well, actually, this is a whole different thing that needs to be protected differently.
And the value,
it's very cool.
There's value in protecting each of these. Each of them have the right to live as much as we do. And if you haven't listened to the tribute to Roger Payne podcast that we did the last episode, be sure to listen to that, because his legacy, he passed away recently, but his legacy is basically that, like, what we're learning about these animals and how amazing they are should be the impetus and the reason why we conserve them. And then we need to know about these individual populations and understand them to be able to conserve them. And they have and it's going to help us in the long term too. So it's a good connection. So so the Bryde's whale, remember, Sea of Love, Bryde's gentle whale. Do you want to check out a fun little video? It's a little series anyway. But next time we'll probably have a journal review or topic, depending. Let's see. Oh no, we do. Oh no, that's right. We already have something set up. Something fun. We found a recent, when I was doing some research, and I was like, oh, this will be a great one to do. So we'll do a journal review next time. As always, follow us on Instagram and Facebook, and check out our website for our merch. Lots of cool merch to help support what we do. And remember, you can subscribe to the podcast as well. That's another way that you can help. And you get these extra bonus episodes each month that only our subscribers get. So please check that out if you're interested. And with that, have a beautiful summer break or time between these two episodes, this one and the next one. Enjoy the sunshine, and we will see you next time. Bye.
Bye.
This was brought to you by Pacific Mammal Research, a 501c3 nonprofit organization. To learn more about the species we discuss, check out our blog. Head to our website, www.pacmam.org, That's PacMam.org to check it out. Also, help us continue providing fun and educational content like this by donating today. Your help is how we can continue to do our work and share it with you. Thanks.